Good day, class. It's Sir Capistrano again, and welcome back to another discussion for our Math 1 statistics. And for today, we'll be talking about interpretation and uses of standard deviation. Look, for those of you who might remember, standard deviation is actually a measure of dispersion. And by measure of dispersion, it is actually paired with our standard deviation being just the square root of our variance. So when we talk of standard deviation and variance, it actually measures the spread or the dispersion of our data. So by that, if we have larger variances and larger standard deviation, it means that the data values are spread or dispersed. Is actually related to the appearance of our distribution if we are to write or if we are to create what we call that frequency distribution graph. Using that frequency distribution graph, we can actually relate standard deviation and variance to our kurtosis. So having a similar number of samples, if we are to say that we have three or two distribution or two data arrays having different standard deviation, the one with lower standard deviation and variance actually will look like our a distribution that most of the data or most of the observation are actually concentrated about the mean or yung tinatawag nating leptocortic wherein the bulge is actually higher or the values are heavily clustered or piled up in the center. So if we have a dispersion or dispersion, by dispersion I mean variance and standard deviation uh, having large variance and standard deviation for the other data set, we will have a distribution that is actually platycortic, meaning to say maliit yung bulge natin, which means that our data are actually evenly distributed about the center of our distribution or yung tinatawag nating hump. So in that, we can actually use this standard deviation to look into the proportions of our data set. Halimbawa, if we have a data set, we want to know the range of the data. Halimbawa, may mean ka na 5. Gusto mong, tapos may standard deviation ka na 1.5. Gusto mong malaman kung ano yung range nung sa 1.5, range nung uh, data na nasa between ng 68% nung malapit dun sa ating mean. So, pwede natin yung gawin using our standard deviation. And in that, we actually will be having two developments or two measures in that. And those two measures are actually developed by these two mathematicians. One is Russian and one is French. We have Fafnuti Lvovich Chebyshev and Abraham Demovier. Mo. Movier. So, ayun. So, kung na-imagine yung hirap banggitin ng mga pangalan nila being Russian and French. And for Chebyshev, we actually have his contribution actually ranges from the contributions on algebra, probability, statistics, and even some other branches of mathematics. And for Abraham, actually one of his contribution is the doctrine of chances, wherein he studied the probabilities. Isa siyang libro na nagpakita lang ng probabilities ng mga kung ano-anong bagay. And from these two mathematicians, we actually have these two measures or two rules that we can follow in interpreting standard deviation. And we have here the Chebyshev's theorem, named after Chebyshev's, which tells us the proportion of values within any observation. And empirical rule, wherein we will have the 68, 95, and 99.7 proportions under symmetrical bell distribution. So, in that, let's go on to Fafnuti's theorem first. So, we have here the Chebyshev's theorem that says for any set of observations, the proportion of values that lie within k standard deviation of the mean is at least 1 minus 1 over k squared, where k is any constant greater than 1. So yung mga assumptions natin dyan, k is actually greater than 1 and hindi ko na we have here any observation may do. By any observation may do, it can be a skewed distribution, it can be a bimodal distribution. Kumbaga, it may range from our usual bell-shaped distribution or kahit left ano siya, right skewed or left skewed. Pwede rin siyang multimodal wherein you have numerous peaks on your distribution. So any of these distributions, we can actually apply what we call Chebyshev's theorem. And by Chebyshev's theorem, we'll be using this quantity a lot. So to better have an understanding regarding Chebyshev's theorem, I have here two examples that we can solve for this theorem. So we have here example number one. So as responded by Fisher folks, the mean annual income of Fisher folks is 25,500 pesos with a standard deviation of 2,500. So find the income range of income of 88.9% of the Fisher folks. So what we can do here, class, is we just need to determine that range, we must use the Chebyshev's theorem, where we can actually use the 1 minus 1 over k squared. So paano natin ito gagamitin? Since we are asked to get the 88.9% of the Fisher folks, all we need to do is we just need to equate this proportion, since this is a proportion based on our Chebyshev's theorem. We just need to write that 89.89, okay? 88.89%, okay? So we can just rewrite this, wherein we will have here 1 minus k, 1 minus 1 over k is equal to actually 0.8889, and we can actually transpose some of the values here, wherein we will have here 1 minus 0.889 is equal to 1 over k squared. So upon computations, we will have here 1 over k squared will be equal to 0.1111, okay? And so on. Hindi yan mag-end, supposedly. And we have here, upon computations, pwede natin gawin na ano natin. So we'll have your 1 is equal to 0.1111k squared. Tapos divide lang natin sila, both sides ng 0.1111. 1111. So this will cancel out. Tapos ito, yung ating 1 over 0.111 equal to our k. We just need to get the square root of that, and that will actually be approximately be equal to 3. So, anong ibig sabihin yan? So, that 3, or going back to our definition of Chebyshev's, ang ibig sabihin lang nung nakuha natin ng k, we will have their k, i-multiply lang natin yun dun sa standard deviations from the mean. Meaning to say, what will happen, since we have a mean, so para dun sa ranges, dun sa lower bound ng range natin, we will have here this mean. So, just to see that. So, mangyayari lang, we will have their mean, or gawin natin sample mean. Mean plus and minus, since 3 ang nakuha natin dito, we will have 3 standard deviation. So, ang standard deviation natin ay 2.5. So, what will happen here is we just need to get the x bar plus 3s, and the x bar minus pala muna. Minus 3s and x bar plus 3s. So, Ang mangyayari dyan, X bar natin is 25,500 minus 3S. So, 3 times 2,500. So, that will be 7,500. Tama ba? 7,500 minus 25,000. So, that will be equal to 15,000, 18,000. 18,000. So we will have here 18,000 pesos for our lower bound. And we will have here again, we have 25,500 minus 3. That should be plus 3 to 5. So that will be 7,500 plus 25,500. We will have here 33,000. So, ano mangyayari doon? So, the range of income of 88.9% of the future folks is actually, call this, 18,000 pesos to 33,000 pesos is the range of income of fisher folks. Sinartip ko na ha. So that will be our final answer using what we call Chebyshev theorem. Okay? So hopefully malinaw yung pagkakasagot natin. Okay? So, ang sabi ko nga, we have two examples. And the other example is this. So, according to a survey conducted by by Department of Labor and Employment or DOLE, the average age of Filipino being hired for their first regular job is 25 years old with a standard deviation of 1.5 years old. So, or years, not old. Okay, so using Chebyshev's theorem, determine the minimum percentage of data values that will fall between 22 to 28 years old. So what we can do here, actually, class, is just uh, look into this range first. So we have here a range which is 22 to uh, 28, sabi niya between. So our range, kung gusto nating makuha, will be 22 to 28. Then we have here a mean which is 25 years old, and the standard deviation S, which is actually 1.5 years old. Years. Okay. So in here, gusto lang daw nating makita, gusto nating makuha yung minimum percentage na bibilang yung ating 22 hanggang 28 years old. What we can do actually here, class, ay i-plot natin muna yung ating values. Wherein, dun sa plotting ng values, we can actually, since wala naman siyang sinabi kung ano yung tsura ng ano natin, yung distribution natin, i-assume na lang natin na medyo bell-shaped siya. Okay? And we have here a mean, which is actually 25. Okay? So, ang gusto daw nating makita, class, ay yung range mula ron sa 22, which is somewhere here, and 28. Okay? So, kung titingnan natin, class, halos parehas lang yung distance nila sa isa't isa. Ah, so, kung iisipin natin yan, we have here, mula sa 25, may distance tayong 3 papunta rito sa kabila, and may distance tayong 3 papunta rito sa kabila. Meaning to say, kung pag-uusapan natin yung K na ima-minus natin, or yung ima-minus natin, halimbawa dyan, itong ano natin, yung ating mean minus some value of K multiplied to our standard deviation will actually be the same K that we will be using for our 28. Kasi kung isipin nyo, parehas lang kasi yung distance ng 22 at 28 mula sa 25. So, paano ko nasabi yun? Kasi 25 plus 3, that is 28, and 25 minus 3, that will be 22. So, to do this or to get this minimum percentage, all we need to do is determine that value of K. Okay? And how do we determine that value of K? para makuha natin yung ating percentage. All we need to do here is just kunin na lang natin yung K dito sa bandang ito. Okay? And to do that, all we need to do, first step na kailangan natin gawin is get that value. So we have there 28. And the 28 minus our mean, so that will be 25. So we can determine that value of K. Okay? Kasi parehas na lang yung magiging value ng K na yan sa magkabilang side na yan. So basically, we will have here 3. And since 3 is just the distance or yung distance mismo ng ano natin, all we need to do here is just get the value of K, which is actually be equal to the difference, which is 3, over our standard deviation, which is 1.5. And this will be actually equal to 2. And for now, since we have here a value of 2, ang pwede na natin gawin ay kunin na natin yung percentage using Chebyshev's theorem, wherein we will have here 1 minus 1 over k squared, where we just need to substitute that value of 2 to that k. So meaning to say, this will be equal to 1. So, 1. So we will have here 1 minus 1 over 2.0 squared. Okay, so that will be 1/4 to be exact. So you will have here 1 minus 1/4, which is actually be equal to 3/4, which will actually be equal to 0.75, which is, if we express that in percent, we will have here 75%. Meaning to say, we have here the minimum percentage of data values that will fall under 22 and 28 years old will actually be 75%. Okay? So that will be our examples for the Chebyshevs. And regarding the final thoughts or final words regarding Chebyshev's theorem, makikita nyo rin sa mga examples natin, meron tayong actually pattern dun sa nangyari. Ano? Paanong pattern ang sinasabi ni Sir? So kanina nakuha natin, we have exactly K which is equal to 3 and K which is equal to 2. And for those scenario, meron tayo actually special na numbers para doon. So, if we have here a distribution and say kung ano lang itsura ng distribution natin. So, sabihin natin ganyan yung itsura ng distribution natin. Okay. Gawin natin ganyan. Pa rin. Hindi natin nakikita ng maayos yung peaks. So, we have here pa ganyan. Let's say that this is our distribution, or bakit ko ba pinapahirapan pa ang sarili ko, pwede naman isang ganyang distribution na lang. Okay. Say, for this distribution, we have here a value of our sample mean, or kahit na sabihin natin yung ating population mean. So sabi natin, according to Chebyshev's, pwede tayong magkaroon ng mga data wherein yung halimbawa, yung K natin, ang ilalagay kong K dito ay yung ating 1, 2, 3. Okay? So, pag meron tayong K na 1, 2, 3, we can actually have here values that are actually our our sample mean plus our S. Tapos, para dun sa population mean, we can have here our mean plus our sigma, which is actually our standard deviation. Tapos, kakaroon din tayo ng values dito para sa kabilang side, wherein magkakaroon tayo dito ng bigyan natin ng mga marks. So, ayan. Gano'n kalayo yun. Dito. So, we'll have here our x bar plus s and our mu, not plus. It should be minus our sigma. Tapos, pag tinuloy natin yan, para dun sa K, ang K natin ay equal na sa 2, we will have here our sample mean minus 2s. And for this side, we will have sample mean plus 2s. That will be also the same for our population mean, wherein we will have here mu minus 2 sigma. And we will have here mu minus 2 sigma. Okay? So, ituloy natin. So, we'll have here 3s. Pag yung k natin ay 3 na, so we'll have here our sample mean minus 2 times our standard deviation. And we have here mu minus 3s or 3 sigma. And for the other side, ganun din mangyayari. So, we have here mu plus, that should be plus, 3 sigma. So balikan lang natin yung sinabi natin kanina. So kanina, nung sinabi natin, or yung nakuha natin dun sa example nung sa Fisher-Fox natin, we have here a k, which is actually equal to 2. And same for this side, we have k that is equal to 2. And for this scenario, na yung k natin ay equal sa 2, this actually has an approximate percentage, wherein for that approximate percentage, we have here a part which is this is actually at always at least 75% according to our Chebyshev's theorem. And for the part nung sa 3S natin kanina, dun sa example natin kanina, this part, itong part na to hanggang dito, taas natin siya. Yung part na yan hanggang doon sa kabilang side, doon sa may bandang 3S natin, wherein k is actually equal to 3, and we have here k that is equal to 3. This will be at least 88.89%. So, kapag na-encounter natin class, when we are using Chebyshev's, that we encounter this examples that we have 88.89%, gusto nating makita yon. And also, we have to get at least 75, lagi nyo na lang tandaan na yung K para dun sa 75% na yun actually would be K is equal to 2. And for those 88.89% ng proportion ng ating ano, we will have here K is equal to 3. So for any other proportions na hindi K is equal to K is equal to 2 or 3, kailangan na natin mag-compute. Ibig sabihin, ito lang yung mga specials natin. So we have here for K, which is equal to 2 and 3. So that is our Chebyshev's. So tandaan lang natin, pag Chebyshev's, kahit anong Tsuran distribution, mapa bimodal man yan, mapa spread mo siya ng sobra, mapa left or right, skewed siya, mapa bell shape siya, walang problema yung ating Chebyshev's. But for our bell shape, nagkaroon tayo ng special na property for our bell shape, or yung tinatawag nating symmetric na distribution. And for that, we will actually be using what we call the empirical rule. And for this empirical rule, kung makikita nyo, class, this is again another estimation. So for a symmetrical and bell-shaped frequency distribution, about 68% of the area under the normal distribution curve within one standard deviation of the mean. This can be written as mu plus or minus 1 sigma. And we have here about 95% of the area under the normal distribution curve is within two standard deviations from the mean. That is, it can be written as mu plus or minus 2 sigma. And about 99.7% of the area under the normal distribution curve is within three standard deviation of the mean, and this can be written as mu or population mean plus or minus 3 sigma or standard deviation. So, anong relationship nandito sa curve natin kanina? Mag-iiba yung values natin. Okay, so by mag-iiba yung values natin, having that we have a bell-shaped distribution. So, pagandahin ko lang yung bell-shape ko, class. Bell-shaped distribution, wherein our bell-shaped distribution is actually normal, what we call normal distribution. Problema ako sa paggawa ng bell shape. But anyway, so assuming that this is a bell shape, if we have here our mean, And we have here our 1 sigma on this side. Ito ay mu plus, minus 1 sigma minus sigma. And we have here mu plus sigma. Then we have here mu plus 2 sigma. And we have here mu plus, not plus, that should be minus, minus 2 sigma. And we have here our 3 sigma. So, ano lang yung sinasabi nito? So, bago-baguhin natin yung kulay. Ano? So, for the first part, sabi niya, about 68% of the area under the normal distribution curve is within one standard deviation from the mean. Ang ibig lang sabihin yan, itong 68% na to actually, that will fall under this one. So, andito siya sa area na to. Okay. So, itong area na to will actually be equal to the 68% of the whole area under this curve. And for the 2 sigma, so we have here our 95%. Bukod dun sa nasa loob ng 68%, ang 95% natin will be this area. So that area within our mu or mu plus or minus 2 sigma. And para dun sa mu plus minus 3 sigma, yun naman yung ating magiging 99.7%. So, yung green na yan, that will be our 95%. Okay? And kung kasama na tong 3 sigma natin, yung mga ibang kulay ulit. So, pag kasama na yung ating 3 sigma, that will be 99.7% of the area under the normal distribution curve ay magiging within siya sa ating sigma or ating mu plus or minus 3 sigma. So that is our empirical rule. So kung yung Chebyshevs natin, we have here there the 75% and the 88.89%. For the empirical rule, we will be having here our 68% for 1 sigma plus and minus 1 sigma, 95% for plus and minus 2 sigma, and 99.7% of our plus and minus 3 sigma from our population mean. So that is our empirical rule. And to illustrate how we can use our empirical rule, I have here an example. So scores from standardized IQ tests have a bell-shaped distribution that have a mean of which mean equal to 100 and a standard deviation which is equal to 10. So describe the distribution using empirical rule. So being this is a bell shape, ibig sabihin we can write or we can use our empirical rule. So again, what we can do here is write our 68% para lang tandaan na natin, we have here the 68%, we have the 95%, and our 99.7%. So, yan yung mga kailangan lang nating tandaan, okay, regarding dun sa empirical rule. So, pwede na nating sulat agad yung tatlong yan para lang matandaan nyo na kung ano yung mga paglalagay nyo. So, sabi niya, 68% under empirical rule, 68% is is the area within the mu plus or minus 1 sigma. So we have here our mu, this is our mu, and we have here our sigma. So what we can do here is just we need to add and subtract 1 sigma from 100 to get that 68%. So for the lower half, we will have here 100 plus minus 10, which is 90. Okay? So we have there 100 plus 10. So that will be 110. Okay? So paano na natin isusulat yun? 68% of the scores is within 90 to 110. So, ganyan lang natin siya isusulat. So the same applies for our 95% or yung sinasabi nating meron ito na yung ating 2 sigma naman, plus and minus 2 sigma. So ganun lang ulit. We just need to add and minus 2 sigma to our 100 to get our range. So ibig sabihin lang yan, since ang sigma natin ay 10, we will have here 2 times 10 which is 20. So we will have there 100 minus 20 and 100 plus 20. So, meaning to say, 95% of the scores is within 180 to 120. And also, same goes for 99.7%. All we need to do here is just multiply 3 to our sigma or our standard deviation. So, we will have there 30. So, 99.7% of the scores is within 70 to 130. So that will be the application of our empirical rule. Wherein using empirical rule, we have described that the distribution, this bell-shaped distribution, uh, in this bell-shaped distribution, we have 68% of the scores is within 90 to 110. We also have 95% of the scores is within 80 to 120. And 99.7 of the scores is within 70 to 130. So that is how we apply our empirical rule. So in that, that will be all for this video. If you have any questions, don't hesitate to write a comment in there or send me a direct message. Bye bye.